number 9, 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 number 9.
Welcome to video number 9. I got a little cartoon for you here. The imaginary number telling the irrational number to be rational, and the irrational number telling the imaginary number to get real. Have a warm-up problem for you today. So we started learning about imaginary numbers yesterday and complex numbers a little bit. I want to talk about how to deal with those complex numbers today. But before we do that, I'd like you to try to simplify the square root of negative 18 for you there. It should only take you a minute to pause or so. I'm excited about this one. We got a special guest today that's going to explain the warm-up for us. Mr. Steiner came in. He would not be on camera, but he said he would explain it if I let him stay off camera. So what I did is I worked out the problem, and I'm just going to let Mr. Steiner take it from there.
All right, thank you. All right, so you got square root of negative 18. It's negative, so I tried to put in my calculator. Calculator wouldn't do it, so I took out the negative sign. I took out like a negative 1. You got negative 1 times 18. Now 18 is a 2 times a 9, and a 9 is a 3 times a 3. So the 3's going to come out. 3's going to come out is bottom line. And the I is there because of the negative. It's going to be 3i and then a square root of 2. So that's going to be the answer there. All right, that's good.
All right, thanks, Mr. Steiner. Appreciate it very much.
Got it, boss.
All right, so hopefully that made sense to you. And what we're going to talk about today is, all right, what are these complex numbers? Now that we know about the imaginary numbers, we know about that I being the square root of negative 1. These numbers are part of a number system called the complex numbers. And the complex numbers look like this. They look like A plus a BI. This is one number. Even though it's got two terms, it's considered one number. That complex number has a real part and an imaginary part that are separate. We looked, the very last example we looked at on yesterday's video, it ended up 3 plus 5i. We said, hey, we can't combine these two things. They're not like terms, so we just leave them as one big number. And that's what a complex number looks like. So the complex number system is what incorporates all these imaginary numbers into mathematics. And so what we're going to talk about today is, now that we know what a complex number is, how do we do the things with complex numbers that we learned how to do with real numbers so long ago, like just simply adding and subtracting complex numbers. So I have a couple examples here. In blue I have an addition problem, and in red I have a subtraction problem. The good news here is, if I just, without showing you anything at all, just say go ahead and take a guess as to what the answer to that blue problem is, you would probably get it right. Because that I looks like a variable. Even though it's not a variable, even though it's a number, it behaves like a variable. In that, when we combine our like terms, we want to combine the regular numbers. So here 2 plus 4 would be 6, what we call the real parts. We're combining the real part of this complex number and the real part of this complex number. And the same thing with the imaginary parts. We have a 3i plus a negative 5i. So that'd be a negative 2i. And so my answer would simply be 6 minus 2i. You can't simplify anything more there because the real part and the imaginary parts aren't like terms. So my answer would be 6 minus 2i. Subtraction works the same way. Right? Just combine your like terms. 2 minus a 4 would be a negative 2. Be careful of your signs here on the imaginary part. Look, you've got 3i minus a negative 5i. It's like having 3i plus 5i. So this is going to be an 8i at the end. Okay? So negative 2 plus 8i. That's all there is to adding and subtracting complex numbers. Simply combining like terms, what we would think of it as. Combining the real parts, combining the imaginary parts. That's all there is to addition and subtraction. So what about multiplication? How do I multiply two complex numbers? An example here, ready to go. Now, think back, where have we seen something that looks kind of like this in a multiplication problem? It should remind you of FOIL, right? it's two things that look like binomials. They each look like they have two terms that we're multiplying together. So we would expect to do would be FOIL, or the distributive property. And you do use the distributive property. You do use FOIL. That won't give you the final answer, but that will get you part of the way to the final answer. So let's start by multiplying this out with FOIL, or the distributive property. Doing our first times first, 5 times 3, 15. The outer terms, so here's my 5 times 3. The outer terms, I'd have 5 times a positive 2i, 10i. Inner terms, 6i times 3, 18i. And then finally the last, 6i times a 2i. 6 times 2 is 12. And then I times I, we'd have I squared. Just like if that were x times x, we'd have x squared. Okay? So there is our distributing the 5, distributing the 6i, getting the FOIL done. We're used to combining these like terms in the middle, and we do here. So this would look like 15 plus, that's going to be 28i plus 12i squared. And if this were a FOIL problem, if I were a variable, we'd be finished. All right? This looks like a quadratic. We'd be finished at this point. However, there's a little bit more to do, because remember, I is not a variable. I is a number. I is the imaginary number. All right? So I is the square root of -1. What we find out here is we do have a 15, which is definitely a real part, and we have a 28i, which is definitely an imaginary part. Now this 12i squared at the end, it's got to be either real or imaginary. There's only two options. It may surprise you which one it is. So we think about 12i squared. Well, if I is the square root of -1, then what's I squared? Well, it would be the square root of -1 squared. The square root and the square would cancel out, and we find that I squared is -1, right? I squared is equal to -1. So while I may be imaginary, I squared is real. Right? I squared is simply -1. So we can use that to help us simplify this problem a little bit more. All right, so we still have our 15 here. We still have our 28i. But now instead of 12 times I squared, since I know what I squared is, I'm going to make this 12 times -1. Right? So 12i squared actually becomes the real number, -12, at the end there. And so when I combine my like terms in this last step, it's actually these two terms that are like terms. They're both real numbers. 15 minus 12, we get a 3, plus 28i. And that's what our final answer is going to look like. So when we multiply complex numbers, it starts out like a FOIL, like a distributive property problem, but then we can simplify. We can use the fact that I squared is -1, and I'm going to take this and I'm going to substitute it in for I squared. And then I'm going to simplify further. So my final answer should look like one of those complex numbers, that a plus bi, where you got the real part and then you got the imaginary part. Okay? So why don't you give one a shot? Here's a multiplication problem for you to pause and try. All right. So we begin by FOILing. 8 times 5. 8 times the -7i. 2i times 5. And then 2i times -7i. So -14i times I is going to be I squared. There. All right. So we do our FOIL. Combine our like terms. All right. So we get a -46i in the middle there. All right, so far so good there. Now, remember that I squared is -1, right? That fact is always going to be there. I squared is always going to be -1. So I'm just thinking, hey, isn't I squared -1? And it is. And I'm going to substitute that fact into this to simplify it a little bit more. So this becomes 40 minus 46i. Now I've got minus 14 times a -1. So that last term becomes a real term, becomes plus 14. So I can combine my like terms at the end and get 54 minus a 46i. Right? So that's how we multiply complex numbers. Remember, addition and subtraction simply looks like combining like terms from algebra. Multiplication starts out, what it looks like is FOIL, and then with some extra simplifying because the fact that I squared is always negative 1. The last thing we need to talk about is how to divide complex numbers. That's a slightly more complex process because it's complex. We're going to do that tomorrow. So I'll see you then.